Hi there. So in this section, we're going to look at variables, expressions, and which will ultimately lead us into being able to solve equations. All right, so we'll first get started here with a few definitions. A variable is a letter or symbol used to represent a quantity that can change. So you can look down here in example 2, and in example 2, part A, P is my variable, versus in letter B, X's are my variables, and in letter C, the N is my variable. Okay, so that's the idea that there. A constant is a numerical value that does not change, and a coefficient is always a number in front of your variable. So coming on down then to example 1, we'll do part A here together. It says the cost for fixing a broken AC unit that takes H hours to repair is given by this expression here, 75 plus 15H. It wants us to find the cost for repair that takes 1 hour and 3 hours by substituting those values into the given expression. So again, we're going to do A here together. We want to figure out what would be our cost if we had someone come out and spend an hour. So here's our formula, 75 plus 15H. And so in place of that H, we are going to put in the 1. And from here, it's just an order of operations. So we know 15 times 1 is 15. And then 75 plus 15 would land us at $90. So that would be your cost if they came out and it only took an hour to do the job. I'll let you do B. All right, let's get on down to example 2, and let's do A and B on this one. Okay, so it wants us to evaluate these expressions for the given variables here. So here, 12p minus 16, and they want us to evaluate it for p equal to -2. So what that means is everywhere we see a p, we're going to plug in -2. So I have 12 times -2 and then minus 16. Do that multiplication first. 12 times -2 gives you -24 minus 16. And then add those together, and that gives you 40, and keep it negative. So -40, final answer there. Let's move over to letter B. Letter B, here's our expression, and for each of those x's, everywhere I see an x, I'm going to plug in -3. So I have 4 parentheses -3 squared plus 7 times -3 minus 20. So everywhere I see an x, I'm plugging in -3. According to order of operations, I've got to square this -3 before I can multiply by 4. So I'm going to burn a step here. -3 squared is like saying -3 times -3. So a negative times a negative gives you a positive 9. Now you can, from here, you can just go ahead and do this multiplication. So I always like to say, let your operations determine your signs. So here our next step is 7 times, actually, let me just go ahead and just bring this down. Let's do it. Let's just do one thing at a time. We took care of the -3 squared. Now, my next step then is let's go ahead now and let's take care of these multiplications. Let your operations determine your signs. So 4 times 9, that's going to give me a positive 36. The next one, positive 7 times -3, that's going to give you 21, but a positive times a negative is a negative. So I'm going to have minus 21 minus 20. And then from here, I'm going to work my way left to right. So 36 minus 21, that's going to give me 15 minus 20 for a final answer then of -5. Okay, I'll let you stop the video and try example C on your own and check yourself by the solution key. All right, so now let's talk about combining like terms and being able to simplify expressions. Like I said, working our way up to being able to solve equations. So like terms terms are the building blocks of any expressions, and like terms are terms that have the same variable part. Okay, so terms that you see here is some examples are here below. So let's you look at those. Like terms, like I said, they have the same variable part, okay, including the exponent. So these are examples of like terms, 6x and -4x. The numbers do not matter, but the variable parts matter. So they're both x's. The next set, they're both x squared y's. So those are like terms. And then in the last set are just numbers, so they're considered to be like terms. Okay. Let's flip it over then to the next page. Let's talk about the addition and subtraction properties. So with your addition and subtraction properties, essentially you are just combining, what I like to say is combining like terms. So you combine them and then let your operations determine your signs. So let's look at A and C here. So in example 3, we're simplifying it by combining like terms. You have n plus 0.04n. In front of that end, the first end doesn't have a number in front of it, but if it doesn't have a number, there's an imaginary 1 sitting in front of that. So now this is like 1 plus 0.04, or you can think of it as a dollar. So a dollar plus 4 cents, they're both n, so I get to combine them. That becomes 1.04 n. Final answer. Okay. Now let's come on down to part C. I'm combining like terms if I have any. So here I have an a squared on the first term, and then back towards the back I've got another a squared. So those are considered to be like terms that can be put together. I've got a -8 and a -3. Combine them and they become a -11 a squared. And then the only two terms that you have left are an a and a -5. They're not like terms, so you just bring them down. Plus 10a minus 5. Okay, so only terms that are like get combined. We'll do one more. Let's look over here at letter B. If I'm combining like terms, I can combine my x's together. So 8x minus 12x. So 8 minus 12 gives me what kind of 4? Hopefully you agree, a -4x. My y is 6y plus 3y. So 6 plus 3 is a positive 9y. I'm letting my operations determine my signs, okay? All right, so now let's come on down and look at our multiplication and distributive properties. And again, I would tell you, you try example D. Make sure you're getting good with that, and check yourself by the solution key. How do we know the difference between the multiplication and distributive properties? It's very subtle, and essentially in both cases you're multiplying. It's just how many items are you multiplying by. With the multiplication property, you are simply multiplying you're just multiplying it by one single term. So in the box over here on the left, this is the multiplication property, because I just have to say 5 times 4, which gives me 20 x squared y, and that would be my final answer. The distributive property is whenever you're taking a coefficient on the outside and you're multiplying it times more than one term inside that parentheses. So in our case here, I'm going to say 3 times 2x, which gives me, sorry, there we go, 3 times 2x, that gives me 6x, and 3 times -7, so a minus 21y. A minus is the same thing as a negative. You want to get away, you don't want to write plus a negative. You want to let your operations determine your sign. All right, so now let's come on down to example 4. In example 4, it tells us to simplify by either multiplying or distributing. Let's do A and B on here. So, and again, like I said, the multiplying and distributing, in both cases, you're still multiplying. The only difference is with multiplication, you're just multiplying by one term. With distributing, you're multiplying times many terms that are in that parentheses, more than one term. All right, so in letter A, -6 times 8, -48 xy. Moving over to letter B, take this -8 and distribute it, okay? Terms are always separated by addition and subtraction signs. So I'm taking -8 times 4n, gives me -32n. -8 times -5, negative times a negative gives me a positive 40. Okay, I'll let you try C. All right, let's come on down to example 5, and we'll do A and B here together. So this one is going to require that we are going to distribute first and then combine like terms, okay? So in letter A, the first thing I want to do is I want to take this -4 and distribute it to the parentheses only. It only gets distributed to what's directly behind it in parentheses. So -4 times 2c gives me what kind of 8c? Hopefully you agree, negative. -4 times 1, so -4. I'm going to bring down the -3 and the positive 11. And then I'm going to combine like terms. -8 and -3 combine to give me -11c. Combine your numbers. -4 plus 11, give you a positive 7. Final answer. And then let's move over to B. I'm going to take this 3 and distribute it to the first parenthesis. So 3 times 4b, 12b. 3 times -2, so -6. In the second parenthesis, you have a minus sign sitting in front of that parenthesis. That is like an imaginary -1 sitting out there that needs to be distributed into that parenthesis. So -1 times 6, -6b. -1 times 3, -3. Then we combine like terms. So 12b minus 6b will give me 6b. -6 and -3 combine and give you -9. Final answer. Okay, I'll let you try letter C. I'll flip it on over then. Next page. We're going to start looking at the difference between an expression versus equation here. An equation is a statement where two expressions are set equal to one another, and a solution is any value of the variable that makes that equation true. You can always check your solution to an equation by substituting in your solution into for the variable, and if you get the same number on both sides of the equals mark, then it's a solution. If you don't get the same number on both sides of the equals mark, then it's not a solution. So I'll demonstrate that here in example 6. In example 6, it wants to determine if these variables, the value of these variables is a solution or not to the equation. So what that means here in letter A is everywhere I see an H, I'm going to plug in 4. So I've got 42 equals 1050 times 4. And what I'm trying to do is I'm trying to figure out, does 42 equal 1050 times 4? So sure enough, if you put in your calculator 1050 times 4, you are going to land at 42, and since I have 42 on the left-hand side, I've got both sides equaling each other. So here, yes, 4 is a solution to that equation. Now, conversely, if we come over here to letter B, everywhere I see an X, I'm going to plug in 5. All right, so everywhere I see an X, I'm plugging in 5 plus 18 equals 8 times 5. So over here on the left-hand side, 5 times 5 is 25 plus 18. On the right-hand side, 8 times 5 is 40. On that left-hand side, when you add those together, that should put you at, what, 43? Well, 43 definitely does not equal 40. So in this case here, 5 is not a solution. So that's going to be a way that you can check yourself whenever you're solving equations here in a few moments, is that once you get your answer, you can plug it back into the original equation to make sure that you get the same thing on both sides. If you didn't, then that means you solved the equation wrong, okay? All right. Down below, you're looking at the addition and subtraction properties of equality. And all that is saying is that if you start with an equation, A equals B, if you add something to one side, you got to keep it balanced. So you got to add that same thing to the other side. All right. So, and likewise with subtraction, if you subtract something from one side, in order to keep it balanced, you've got to subtract it from the other side. Think about whenever you're solving equations, think about treating it like a balance, like an old-fashioned scale that you've got to keep it balanced. Okay. So looking at the example over on the right, it wants us to solve here for x. So my goal is to get this x all by itself. So in order to get this x all by itself, I got to bring that 2 to the other side. Another thing I always like to say when I'm solving equations is my goal is to get letters on one side, numbers on the other. And so in order to get that x all by itself, I need to get that 2 to the other side. I got to undo it. Right now it's adding 2, so the opposite of that would be to subtract 2. That way I'm keeping it balanced. I did the same thing on both sides. Positive 2 and negative 2 cancel out, just leaves me with x on this side. 10 minus 2, of course, gives me 8. That would be my solution. And I will show the check on this. Okay, so that means go back to my original equation. Everywhere I see an x, I'm going to plug in 8. So 8 plus 2, trying to make sure that equals 10. And sure enough, 10 equals 10. So x equals 8 is your solution there. Okay. And I wrote that thing a minute ago where I said your goal when you're solving an equation is to get letters on one side of the equals mark and numbers on the other. Okay, that's always going to be your goal when you're solving equations. All right, let's flip it over. I believe we're going to pick up, actually we're going to do a couple just a practice here. So let's do A, B, and E together, and then let you pause and try the other 3 on your own, okay? So our goal here is to solve these equations, and it does say check the answer. I'll check the first one with you, but after that I'll let you do the check part on your own, okay? All right, so in letter A here, my goal is to solve for M. So you notice then is that 3.85 is already on the right-hand side, already all by itself. So I'm going to bring that 2.73 to the other side by doing the opposite. Right now it's a positive 2.73, so I'm going to subtract 2.73 from both sides. That cancels out, just leaves me with the M on the left-hand side. When I do my subtraction over here, I get 1.12. So that would be my final answer. And then, like I said, I would show the check on this first one. So it's just like we did on that last one. I go back to my original problem, and everywhere I see an M, I'm going to plug in 1.12. So I have 2.73 plus 1.12, trying to make sure that that equals 3.85. And sure enough, if you We're to add those two together, you get 3.85 on the left-hand side, and that's what we already have on the right-hand side, and that's the way you know that you have the right solution, okay? You haven't made a mistake. All right, we'll move over to letter B. In letter B, my goal is to solve for this k to get k all by itself. So in order to do that, I got to get rid of the negative 3. So since it's a minus 3, to do the opposite, anytime you cross the equals mark, always do the opposite. So positive 3. Those 3's then cancel out because one's positive, one's negative. It leaves me with k on that side. 8 plus 3 is 11. Another good technique for whenever you're solving equations is to try to keep yourself lined up down that equals mark. Okay, so here k equals 11. All right, and then like I said, let's come on down to letter E here. Fractions here, so don't let that scare you off. I want to get this x all by itself, so I want to get rid of the 2/7, take it to the other side, do the opposite. So right now it's plus 2/7, so subtract 2/7. Cancels out on the left-hand side, just leaves me with x. I'm going to bring down my equals mark. I already have the same common denominator, so I already know it's going to be 7ths. 5 take away 2, 3/7. Final answer. And you could eyeball this one as far as like checking yourself. 3/7 plus 2/7. Yep, sure enough, that gives you 5/7. Okay. All right, so let's move on down then to our next piece where we're looking at our multiplication and division properties. Still with that same idea with our old-fashioned scale. Whatever you do to one side, do to the other. So if you multiply one side by something, then you got to multiply the other side of the equals mark by that same value. Likewise, if you divide one side of the equals mark by a value, then you've got to divide the other side of the equals mark by that same value. Let's do A and B down here in example 8 together. All right, so in example 8, I want to solve for x. So in order to get that x all by itself, this is 8 times x. So to undo multiplication, just divide. And like I said, whatever you do to one side, do to the other. Those 8's cancel out. That leaves me with x. So you get x equals 4/8. Now remember, always reduce. So 4 and 8 have what in common? You can divide them both by 4. Always look for the highest. So 4 divided by 4 gives me 1. 8 divided by 4 gives me 2. X equals 1/2. Final answer. Okay. These can still be checked. So I'll show another check for you. Go back to the original problem. Everywhere we see an x, I'm going to plug in 1/2. So 8 times 1/2 equals 4. And sure enough, 8 times 1/2, think of that. Half of 8, that's 4. So 4 equals 4. We're good to go. All right, let's move over to B. In letter B, I want to get this x all by itself. Right now it's being divided by 4, so to undo multiplication, just multiply. So that way, got a 4, and those 4s, one's on top, one's on the bottom, so it's going to cancel out. Just leaves me with x. And on the right-hand side, negative 2 times 4 gives me negative 8. And again, you can kind of eyeball the check here. Negative 8 divided by 4, yep, that would give me a negative 2. So final answer. It's probably a good idea just to go ahead and look at letter C there. Anytime you have a negative sitting in front of a letter like that, again, it's an imaginary negative 1. Can't leave that negative 1 sitting there. It's multiplication, so negative 1 times that x. Divide both sides by negative 1. Cancels out the negative 1s and just leaves you with x. 5 divided by negative 1 leaves you with what kind of 5? We agree it's a negative 5. Final answer. Okay. Let's flip it over then. Last page. All that we want to pick up here on the last page is solving multi-step equations where you might have to do combine like terms and then either add, subtract, multiply, or divide in order to solve your equations. I give you a little bit of a framework to work by. I say simplify on both sides of your equation separately if needed, using your distributive property, combining like terms. Always remove your parentheses first. Then you want to isolate your variable, okay, using your addition and subtraction property. And then isolate the variable last by using your multiplication and division properties. Get rid of those coefficients. And then lastly, you can always still check your answer. Okay, I probably won't continue to demonstrate that, but you can always check your answer when you solve an equation. All right, so let's look at A, B, and C here on this one. So in letter A, I don't have any distributing or any kind of like terms, so my goal then is to get closer and closer to getting this k, this letter, all by itself. So in order to do that, I first need to get rid of that minus 3. So I'm crossing the equals mark, I've got to do the opposite. So the opposite of minus 3, I'm going to add 3 to both sides. Cancels out, so now I'm left with k divided by 3 equals 13. Last step, I want to get that k all by itself. So right now it's being divided by 3, the opposite of division, multiply. Whatever you do to one side, do to the other, keep it balanced. So that cancels out, just leaves me with k. 13 times 3, 39. Final answer. And again, you can still go back and check yourself. And then I can verbally say it. 39 divided by 3 would give you 13. 13 minus 3, sure enough, is 10. Okay. Let's move over to B. Letter B, all my variables are on the left-hand side, but they're like terms, right? You got a couple of x's here. It's imaginary 1x, so 1x plus 0.12x, it's like, remember that thing like $1 plus 12 cents, so I've got 1.12x equals 672. So I've combined like terms on first on this one. Divide by the number beside your letter. Cancels out, because remember that was multiplication, so to undo multiplication, I'm going to divide. Do that division, and that comes out to be a nice 6. X equals 6. Okay. And then let's do one more here together, letter C. All right, so I want to solve for G in this one. So the first thing you'll notice is I've got a couple of G's in this problem, so let's combine like terms. 4G minus 8G, it's on the same side of the equals mark, so you're just combining like terms. So 4 minus 8 gives you what kind of 4? We agree, a negative 4G plus 10 equals a negative 36. Now at this point, that negative 36 is over there all by itself. Take the other number over to join it. You want to get that letter all by itself. So let's take the 10 over. I did the opposite, so I subtracted 10 on both sides, cancels out. So I've got negative 4G equals, what's that, a negative 46? Divide both sides by negative 4. All right, so that cancels out, just leaving with G. Now I've got a negative over a negative, so that's going to give me a positive. But 46 and 4, they're both even, so I can divide them both by 2. So divide them by 2, get 23 over 2. Final answer. Okay, I'll let you try letter D. Let's come on down to letter E. Letter E is really, it's just a word problem, but it's right in line with what we've been doing here in this set of notes. It says the population of Nebraska can be estimated using this equation here, where P represents the population in thousands, and T is the number of years since 2000. He wants to know, in what year will Nebraska have a population of 1,850,000 people? So what that means then is that I'm going to write my formula here. P equals 9T plus 1706. I want to know in what year, so I'm trying to solve for my T here. I know what my population is, 1,850, and that's in thousands, so I'm going to put the 1850 here in the population spot. And I'm going to be solving for that T. So I want to get closer and closer to getting this T all by itself. So I'm going to bring the 1706 to the other side, crossing the equals mark, so I'm going to do the opposite. Right now I'm adding 1706, so I'm going to subtract 1706. Cancels out, so I'm left with 9T equals, subtract that, and that should have put you at 144. All right, I'm going to get T all by itself. This is 9 times T, so to undo multiplication, divide. 144 divided by 9 will give you 16. So remember, that's 16 years. T represents the number of years since 2000. Okay, so to figure out then what year we're talking about, my T would be, or the year, T is 16, but the year itself would be equal to 2000 plus the 16 that we got, or the year 2016. That would be my final answer, the actual year itself. Okay, all right, that finishes up this section.